Okay, welcome. The following is a video which it's the first of three videos to talk about collections. Collections in the LNSKI object database are basically ways of representing composites in your object models. So just to start off with, let me give you a quick overview of objects. So here I have this really basic presentation. And when I talk about composites, I'm talking about this kind of representation inside of UML. So basically a player can have many inventory instances, and the solid diamond here is to indicate that whenever the player is removed from the environment, then all of the associated inventory instances are also removed. Now, when we're talking about object models and even the LNSKI object database, we can actually describe a player and store all of the inventory as a single object. If you were to do this with a relational database, you actually have to create two tables. One is a player table or player tab, and the other is the inventory tab, because there's no way to represent all of these individual inventory instances on a player tab. You actually have to do the split. So the first thing that you have to do with relational databases is you have to map things. For example, in an object model and my object database is, you'll notice that string here is just a string. But in a relational database, you have to start specifying sizes. So in this case, this name gets mapped to a variable character field that's up to 50 long. So if you have a name that's 60 characters long, you're basically out of luck. You can only use 50. The other thing that's a little bit obvious is there is no vector 3 inside the database. So now you have to break apart your position X, Y, and Z into appropriate numeric fields. And if your position is too large for the numeric fields here, again, tough. But that's how we've always done it, right? We've always taken our object models and we've always mapped them, this object relational mapping, to get, here's our player representation, here's our inventory representation, and this is how it's going to be represented inside of tables. The other thing is, because inventory can't be stored with a player tab, it has to be created in its own sort of cosmos or world, right? So the inventory tab has to have its own object identifier, and it also has to have some kind of relationship between the inventory and the player. So once we take all these inventory objects and store them in this inventory tab, we now need a player OID to basically point back to this player. So in a way, our table representation is implemented as an aggregate rather than a composite. And while there's really minor differences, if you don't implement it properly, you can end up with orphan data. For example, if you create the player tab and you don't have proper relationships between these two tables, you can be left over with inventory tabs that don't actually have player tabs, and of course that creates a mess. So that's basically the difference between the object database and a relational database. So inside of my environment, I have three examples, one dealing with lists, one dealing with arrays, and one dealing with dictionaries, and I'm going to have three separate videos for each of the three. So in this particular area, what we have are 4 scripts, and they're attached, not attached. There's 4 scripts in this scene. There's a create players, show players, and then there's 2 in behind the scenes regular run-of-the-mill classes. It's player that actually implements the EODB class interface. So I'm just going to jump in and show you what the player class looks like. So here's my area, and this is the player class. And I'm just going to close up some of these guys here and then talk about it. All right, so when you implement EODB class, it implements 3 fields: the database, the object identifier, and a version number for your object. It also implements the class name definition, and save. So the save is a standard save when dealing with objects. You just say EOB descriptor this, and this will be the class that gets saved away, whatever the values are. When you're loading new objects into the environment, what you do is you have one of two possible constructors. In this example, the constructor it passes in the database, it passes in the name and the position. I set the values, and I set this list to essentially a new list. If, on the other hand, if I happen to have an object identifier that's provided for me, and I'll show you how that actually occurs a little bit later. Basically, I do an EOB descriptor with that object identifier and this. So basically, the system will go figure out what all these fields are and put the values into this instance. Now, in order to work with inventory, so basically you create a player, and then you want to add some inventory to that player. So basically what I do is I grab the name of the inventory and the count of the inventory, and I create a new inventory instance, and I stuff it into this list. So the inventory looks like this, and it's really simple and straightforward. It's basically just the name and the count, and then there's a constructor that accepts those two things and assigns them. So there's nothing special about this inventory. Now, for the implementation of EODB class, the class here is just a name. So whatever the player is. Later on, I'll show you how to use a constant to have a little bit more consistency, but right now it's just returning the player. And then whenever you're doing a save or whenever you're doing a load, for example, through here, the descriptor will in turn call the definition object. So the definition for a list is fairly similar to previous tutorials. There's two structure objects, one for the name and one for the position. And then there's some extra code here for dealing with the collection involving a list. First off, there needs to be a test to see whether or not this descriptor is loading, and if it is, then we want to construct a new list for inventories. And the other thing that has to happen is we have this thing called a collection. So it's a new method that you can call, and you provide it with an inventory definition, which is this guy here, and the inventories, which is the list way up here. So what happens in the inventory definition? Basically what happens is when you call the collection, it's basically going to loop through this inventories list and call the inventory definition method. So basically what it's going to do is you'll get several of these being called when you're doing a save. And when you're doing a load, you essentially ignore them and just add your values into this inventories list. So basically what happens is we're looping through this inventories list and calling this for each instance. So when we're doing a save, so ignore name here for a moment. When we're doing a save, we're just going to get an inventory in. So we just write out the inventory name and the inventory count. And when we're doing a load, we basically need to remember what the name was. So basically this A gets assigned, or sorry, name gets assigned by A. And then when we construct, or when we're adding this inventory, we just basically say, okay, here's my inventory list, which is coming from here. And I say add new inventory name, which was in the previous step, and then A. So that's how new inventory gets created and added to this collection. And that's how it works. So the next thing I want to show you is how players get created. So I'm just going to open up the player script. And so here's all the calls that are occurring. I construct a new player, give it some field attributes, and then I add inventory to it, and then I save it away in the database. And then I repeat the same process for player 2. Mary, here's the location of Mary, and then here's all her inventory, and then Larry and all his inventory. And so let's actually run the create players script. So right now we're going to be loading up in Z tutorial DB collections. So right now inside of this directory, there's nothing in there. So I'm just going to go ahead and create players. So the script is now active. This show players is not going to do anything. So I'll just run play. And it's gone ahead and created this collections database, and it contains 238 bytes. Now, when I'm finished with it, I'm going to close this down and I'm going to do show players. So let's show you what the show players does. And it's also very quite simple. It first of all goes into the database, and well, obviously it opens up a database, creates a string builder here just to simplify the output. And what it does is it goes into the database and it says, find me all the object identifiers for a class called player. So if you remember back in the player class, under the class name, it's player. So that's what it's actually extracting. So what it's going to return is just a list of all the object identifiers. Then we construct one of these player objects. Since we know we're getting actual object identifiers out of the database, what happens is we get all those entries, and for each player OID, we create a player. So what that's doing is going into this this constructor assigns the database, and then we have the object identifier, and then we have a descriptor that says, okay, let's load up this object identifier and put it into this class, which of course we're now constructing. So for show players, so that's how our player gets created, and then we go ahead and write out some information about our player, and then we go into the inventory, and this is how we pull through the inventory. So at this point, the player has loaded and all of the inventories have loaded. So once that's complete, it looks like inventory was always there. So we just basically run through the inventory and run it and see everything. So I'm just going to slide this over here again. Actually, yeah. And we're going to run the show players. So I'll click run show players, and I'll click on the one debug output line here, and you'll notice there's some output. So let's see if it matches. So I'll just go back into create players, and you'll notice, yes, in fact, Joe 001 had 3 apple. Mary had grape, apple, banana, pear, and pineapple, and everything is correct. So this demonstrates that, in fact, it is properly loading all of the players and all of their inventory. Hopefully that helps understand how to use the object database in order to store composite data that involves lists.